So that is a negative, a change of negative 1.0 meters or 1 meter.
Would you suggest having a labeled meter, 2 meter sticks with the points on there? And let's say a golf ball or some type of ball that you could move, for a kid to actually manipulate, to show them those directions?
It's a very good
I
idea.
would put tape on the floor and make a number line that they walk and
okay,
model that.
Okay.
Or
Or,
I was doing,
I'm thinking,
walk,
have
half a meter.
2 meter sticks side by side and put the ball in between the 2 meter sticks and
Yeah.
move it up and down.
Okay, not or, both.
yeah,
You want multiple representations of a concept.
right.
So I'll never forget when Russell was doing positions, and the one that I really, he gave, I don't know, probably 4 or 5 examples, he doesn't even remember, 4 or 5 examples, and I remember when he used the one over the grill and the ant walking. Do you
Oh,
remember?
yeah.
When he gave that example, out of 4 or 5, I said, oh, I get it now. And so I didn't quite get it with the other ones. That's why you don't just have one activity. So it's not or, it's all of them,
Yeah.
multiple examples. AAAS says a student should have not one lab, if you want to put it that way, but 4 to 5 labs on the same concept. That was in 1998. This is not a new idea. This has been in our best practices, however many years, I don't know how many.
A long time.
a long-
So you could have one on the floor, you could have one on one table, one on another, and then, go through all of those. When you say lab,
Or maybe
you don't
even
mean
in
spending a
stations.
whole day on one thing. It's just that many concrete experiences so that you can feel it and touch it and hear it over and over and over, and they're all different. So what might click for you, or what might click for you, doesn't do anything for me. So it may take me having more experiences or different experiences for it to come home. Yes, sir.
Yeah, I'm gonna comment on Tony's idea of 2 meter sticks. Because one idea I've got is, we always have a tendency to start a position at 0. Why? So did we all start our clocks at 0 when we walked in the classroom? When class started, we reset our clocks to 0, or did we just say this is what time it started? So you could have 2 meter sticks that they don't have to be the same. One's got a 0 here, one's got a 0 there. So you can take data for the same motion, using 1 meter stick, or from another meter stick, you're gonna get the same right-hand columns. The positions will be different, but the changes of positions and the rate of change of position will be the same.
So start at a different numerical value, like start halfway down the stick as the starting point,
Why halfway? Why not just have them anywhere?
or, I was kind of giving, yeah,
I mean, you
maybe
could start, I would recommend, having
Pick a point on the meter stick.
where you started at 0. And that, take the meter stick down, throw it down, slide, then you just move them. Because the data shows that at point A, it was here. Then at point B, it was there. It doesn't say anything about in between. It just says it was there, then 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 it was there. That kind of thing. You could do the same, have the same thing, be the same thing, but reading off of a different meter stick that doesn't have the 0 any specific spot. And when you calculate it, you still get the same answer. So, because that's what we're really trying to get to, is that velocity is a property of the motion that is useful, because it doesn't really matter what coordinate system you use to measure.
Change. And I like that idea with the meter sticks. Get a tape, cut off the end of the tape. So you're looking at that change, right? Rather than starting at 0 and measuring one direction and the other.
Whenever I was teaching physics labs, we had these plastic rulers that they were flexible and the students would always break them. So I got those. Then I cut the end curved so that it wasn't on a line. They could not use the end of the ruler to measure it. And that frustrated them because they're all so used to either the end of the ruler or 0 on the ruler. And I got rid of both.
That's why we don't have, if that was true, we only use straight, we wouldn't have any curved ropes or curved anything, would we? Only with know how to calculate semen or anything. It's straight, have to be straight.
Okay, so let's turn the page, number 4, please. Okay, we're gonna work together to calculate the average velocity and average speed for the points between, for the interval between points B and D, and the interval between points A and B. So the average velocity, average is that change over time. We're calculating those numbers between two different points, so that remains sort of the same. And we know that we learned in 6th grade that average velocity, the difference between the average velocity and the instantaneous velocity. And I'm coming from this at an 8th grade level with that prior knowledge of the difference between the instantaneous and the average. So what is instantaneous velocity? Toby?
That particular, I want to say speed, I'm probably wrong, but the speed at a specific,
I'm
What?
sorry, I misspoke. Instantaneous speed
oh,
is what I'm asking.
the speed that you are at a particular moment in time and place.
Okay? So if you get pulled over by a policeman,
And he,
what is he gonna give you a ticket for?
when he pushed that button, or he looked at it, when the machine printed it out, right at that one moment in time, it's not your average speed, because I went to court on this. Then I said, well, I left the house from this point in time, and you pulled me over. No, I caught you right there. So it was at that particular place, that point in time.
So is that instantaneous?
That's
Because the courts say it is not average,
Right,
it's instantaneous speed.
but they still reduce the time.
So if you got in your car here and you drove to Dallas,
Yes.
okay, so you got clocked at 100 miles an hour, you were going really fast. How long does it, if you drove the speed limit, how long would it take you to get to Dallas without traffic? Say 4
Oh,
hours? Okay, so let's say just for big round numbers, 4 hours? So that means that you drove how many miles? Is it, how would I say, it's 200 miles
240.
over 4 hours? Or
Per.
it took
Or-
you 4 hours to drive 200 miles, and that's slow. From my calculations, from my driving, that's slow. But if Toby were driving and it took him 4 hours to go, that means that, oh, Toby drives really fast and didn't get in trouble. Or maybe you did and you had to stop for a while on the side of the road with the lights, and then you had to stop for a while. What was your speed when you were stopped?
It's the speed at the mile marker that you were right at that point.
No, when you were pulled over on the side of the road, what was your speed?
0, yeah, because
Okay.
you stopped, yeah.
So whenever we're talking about average speed, how do you figure that out? You drove to Dallas, it took you 4 hours.
Overall time and the distance traveled.
So how do you figure out your average speed?
Division.
Yes.
Take your distance divided by the time it took.
Right, but what numbers do you use to figure out your average speed on your trip to Dallas? Because, at one point he was going 100 miles an hour, and another point he was pulled over on the side of the road going 0 miles per hour.
Total miles over the total time.
Total miles over the total time. So the total
Divided
distance
by
you
time.
covered. Okay, the time that you spent driving and the total miles you covered. So the total miles you covered, the total distance, divided by the total time will give you your average speed.
Your change in distance.
I was talking about something different.
I don't know, it seems like you're still needing a different answer.
What's that?
Is So you're still looking for a different answer?
No, I'm just
Okay.
wanting y'all to think through it with me. Yeah. So it's the total distance you covered divided by the total time it took you to cover that distance. Gives you the average speed. The police with their radar guns didn't say, Toby, you got to Dallas in 4 hours.
Yeah.
You drove really slow, because that's pretty slow, right? Wouldn't you agree? If he went that speed, if that was his instantaneous speed the entire way there, that would be pretty slow. You would not be the happiest person on the road, or the people around you would not be the happiest person on the road.
I had a professor once that described to me, and it helped me understand it, that the average was the one constant number that would get me to the same thing in the same amount of time. So that an average velocity for Toby, or average speed for Toby going would be the equivalent constant speed that would have gotten him to the same distance in the same amount of time. So all the other traffic that was going at 40, 50 miles an hour, what did we say, 50 miles an hour? They got there the same amount of time as it took him. When he was speeding up, cutting between cars and stopped on the side of the road and all that other stuff, the one constant speed that would have got them there in the same amount of time.
The tortoise and the hare.
So Toby, calm down.
Cruise control.
There you go, cruise control.
Cruise control.
Okay, so go ahead and calculate that average velocity and speed between points B and D, and then between points A and G. And then the next one is to discuss what numbers from your calculations, what those numbers mean. What does it tell you about your dog's motion? So do your calculations first, and then discuss it with your group.
This should be 3.
Oh, you do it between the A and G. Point A, yeah, okay. It in, yes. One meter and 2 seconds. 2 seconds.
B and G would be 2.
Are we looking at time first or positions?
I was looking at just I'm sorry. And I've got the change in position.
Right, from point
One meter. And the change in time is,
or sorry, 2 seconds.
so your velocity is there, 0.5 meters per second. Okay, now between A and G, that's the same. So velocity is
You're starting at the second round. Is that where
Oh, wow, that's interesting. Oh, wow.
So position.
Okay, so how are we gonna do this?
Like it wouldn't have changed at all. If I were a student, I would say, oh, this is 0 and 0. That means
I would say 0, right?
yeah, if I were a student,
That's what I would say. And the time is 6, correct?
right?
The change in time is 6 seconds.
Oh, see, that's the second.
And this is meter. So this is gonna be your answer, it's gonna be 0.
So there's rules about what
Second, I'm saying today.
because if you look at the that's
I know you're at.
Is that what you'll do for intervals A and G too?
They're still mad.
Do you want your students to say you're
Because if I go to Lubbock and then I come back from Lubbock,
What's your
the velocity is change your point. You're just saying. Is it change?
So you're thinking like the number line and the spaces, right?
That's what I would
That's what I'm
write
saying.
initially.
Each individual be counted.
That's where, I gotta wait to hear the answer to this one.
So what do you have?
At zero. But I've got, but conceptually,
Do you want your students to say, I gotta
How
say
could you change it? How could you not change it?
the interval between A and G, or yeah, the average velocity for the interval between A and G. That conceptually,
It just makes sense conceptually, because you move so much and then you're back to the start spot, so there was no something, like, for a teacher, I didn't think that there would be change. For a student, I would just look at the numbers and say, okay, 0, 0, we're back to the beginning.
Well, I think that's right. That's where it comes to go back
So they didn't really change.
so the position wasn't changed.
There you go.
That's what it
That's what they needed to do.
is.
So that would be
There you
the,
go.
that
It started at
the
the same, yeah, so like
You
I
need
went
to
to the
hone
store,
in on.
and when I called you, you're back home. So I don't have to go to the store. Right. Wherever, when I called you, you're back at that station. Yeah.
Makes sense.
It doesn't matter that you snuck out through the bedroom.
Yes, exactly. You can do that scenario, actually, and that would make a lot of sense.
Position didn't change.
Average velocity.
The time is like, that's two, but this is not.
Yeah.
Okay, I see what you're saying. So,
Or she
The change.
the position didn't change, but the distance was covered during that time interval.
That's probably why average is total.
No, the problem is,
What
she is good.
Speed is distance.
And she was doing,
I think Brandon, you're talking about abstract, right? It includes the distance, the total distance covered divided by the time. So I think that makes it different from the velocity. Yeah, then you just take into account like everything, right? All the factors that you traveled.
I don't know, because when you find the difference, you're still using the same.
you have 1 meter of change over the down here. Zero to 6 seconds.
You can't travel
So the
at
total difference,
I always thought distance was positive.
the total difference, like you have to take it on the number line. So I wrote 2, so that's 2,
When her dog
the
ran
distance
from
is, she's gone 2 meters.
0 to 6.
But then when you're going back, it's always gonna be a positive,
Right.
so it's, alright, so it's 3 for the distance.
And then, yes, but now do your speed.
Because you went back.
Now do your speed.
0.
Even if you're going, even though dog would turn around, you're still moving. A distance. So it's a 5, so the value is a 5 now.
Below sea level, that's elevation for one, but
It's gonna be
still a
easier for
positive
the
number.
direction. I said it's gonna be easier.
You know what I'm saying, so I was like,
For me, there's still one.
to me,
We did the six shoulder pride.
What would be the hardest direction?
to me, like, driving back, walking back.
Yes. The bag, the helmet.
Elections, if I was at low sea level, something.
So going in next,
I don't wanna do like
sea level zero.
that's what I did, that's why I thought.
So that's like, yeah,
Right, so you're going in
yeah,
the
going
next.
from your house to the school
But,
and then back to
yeah,
the
that's
house.
So it's basically their full.
We're still moving
Full
forward.
trip.
Okay, so that's why, that's why speed's always a positive. You can't go,
Yes, so you're
you know,
not.
when you reverse, you're not going negative 5 miles per hour.
Well, and we just finished.
But distance can be there.
They were using all these words to
Well,
change
but
it.
here's the thing though, is that their teachers.
No, even if I, what does it
The
say?
thing is,
Even
yesterday,
if I walk through the
and now
door,
the kids, whenever they get to this
Ah,
point,
very good.
they see
Math, do you wait?
see the next one, and
Line over,
whatever
or
it
if
gets
it's in
to.
school, I always have you put one there, and then.
And then they're gonna start doing the power. They're gonna think it's exponents.
That's what he uses it
So for your engagement, it knows not right
Well,
again.
yes. Take notes on what we're covering.
Like
Now,
exponents are the,
covering, then I may go to a different one, but they may see it again later in the year. Covering that.
So,
You know, it's
and if we're
spiral.
doing
But
a,
there is part of
There's
that
120.
peak,
Like some of them have 2, 3, 4.
yeah, and then there's like a
Each slide.
oh,
Yeah, I know that, yeah, or like 1, 2, 3.
Takes a lot of time to do it, but.
so by the time they get to doing this, they're gonna see that, and they're gonna go, well, A equals zero, G equals zero.
Screen stay.
This is a what would be another way to write it?
Each individual little dot.
Oh, they learned that.
I'm kind of confused. I had it further, and then I.
We do that, you know what?
Talk about going from page to page.
This is going to help. If I get to that point, see,
Okay, and what are you getting for this one?
It doesn't necessarily mean you're walking.
Just like
I'm fine with her, you just showed on the second.
are we trying to find
it's quite easy.
the average speed in just those 2 points, or is it like a different separate calculation?
I don't know. Well,
Because, I mean, this doesn't say like find the average speed, it's just open it.
Okay, guys, take a bathroom break for a second, and then we'll come back together. 5 minutes.
Ah,
I got to eat that.
right, you're gonna have to have the man, but I'm working on it.
He moves slow, he actually moves slow.
So they understand.
Distance on change.
That's why I'm thinking.
Because I can help me with it.
Right, and
I have all moved.
I admire you having that perspective, because this right here is a huge stumbling block.
So would you put
Once
your-
having sat through physics planning sessions, I never taught physics, but having sat through planning sessions, I know it's a huge stumbling block. So if the kids, if you can get even a portion of the kids to go on to physics to understand this, you've done a huge accomplishment.
Making sure that I've set them up to be successful when I bring them back.
Right, for your own perspective, and then also for the future down the line when they get older.
Yeah, I left mine in my desk. I'm sick of my kids coming to me. I need us to start putting it on the student, so I have it with me.
I have one more kid tell me, oh yeah, we did this last year. They don't know what they need to know for the 5th grade stuff, but they know my 6th graders.
Because I think I got like a 30 flash drive.
Your 5th
Because I
graders.
knew just has like a new teacher
likes and
Give me everything. Give me everything.
Well, Kim, I'm beginning to wonder if it's
I know it's like a
keying on a word and not the concepts. They really are stealing your concepts.
Sixth grade is one.
Go to A.
There are several.
Whether he's going, wherever they wanna call it, forward, backward, wherever, he's still moving.
Yeah, then you
To me,
realize it was
it's 0.16%.
And we're still on change. Can you see if there's
From
there are
point A
several
to B.
people in our district.
Just like I do.
Love to tell our
He's
teachers.
turning around in the
high level
360.
people.
My position is not going to change.
Go ahead, teach
Right,
them to
because
them.
I'm
It's like
Right.
you're
Change
not
my
looking
position
at
from
the teacher.
getting back where I started.
Appreciate it.
Right.
So
But my speed, I still have to do that at a certain speed.
Show me B.
That's what she asked us, what she found us.
Having been at the receiving end of that, no.
Average speed
And I assume that's
I
what you're
think I have
doing.
those, but it.
You too. Sure.
divided by change.
But yeah, I'm struggling with
So for that being 6 seconds,
Don't teach mine.
So
It
I'm looking
is,
for, to me, I'm moving.
also, my students just don't turn anything.
0.6 minutes per
So
second.
that's been fun.
Yeah, when I get
So
up,
I've had to restructure that class to really sometimes because if they
They can't explain knowledge yet.
I still have to move
They know how to tell them
in some direction.
except for like two
Some numbers, just calculate numbers.
Yep, they can. They can. Like those in first grade on
You
out.
know they're changing.
Because they have to and they have
In order to go, so it's like, in order to go, in order to,
Oh, yeah, we remember how to do
come back
that.
from the store, I have to go there first. Right.
Yeah, I was right there, but for
Or
high school, I mean, they just have like easier classes, so I thought it would just be easier just to do like a binder. So,
Oh, I am right.
yeah, so that's what I'm doing.
But it's like, still, just too much to get.
She didn't give them the foundation, but she gave them the math. They remember the math, but they don't remember. And none of them can tell me, oh, yeah, we did that.
Yeah, I don't know, but
We
like
understand.
I said, they like take home projects out,
Position didn't
like, I
change.
think like third or fourth.
So you've got
And,
to,
over time, I have to teach one,
it's not unteach, I guess you just have to
Come back
give them the,
well, this isn't very been any homework assignments.
So I was mainly doing that.
Let's talk about speed.
That's what I'm finding.
are you finding it comes from one particular elementary school?
Steve is still talking.
Total distance. Distance covered is.
I don't know, I'm thinking math terms.
I don't like the.
Also, that data site, so that is, they were just like, so like, this is gonna be, like, I wanted to, like, this is gonna be, please don't judge me.
Professor Mel.
I found the opposite. And they're not.
Their office hours.
Well, hallelujah.
Your position makes it, thank you.
Yeah.
But distance is not.
Okay.
I don't know.
Get in your car.
When you're talking about the,
That gets deep.
Well, yeah, because I was gonna teach that. You didn't, it does not faze me or anything about label, but you can't do science without tables, and I don't have science lab.
That's why I'm thinking.
So even though you may be going underground,
Underground.
how far underground you went to
We're having a
school?
discussion how.
That's a negative money. That's a negative number.
Just tell them to say it differently. Rather than saying negative 20, say I'm going to below sea level. That way it's not, when it's travel, it's not negative. Below sea level, less 20 underground, because you're under sea level, you're starting from 0, or 0 in the ground, yeah, or sea level. And you know the positive part, in your head, if it's distance, I'm 5 above ground, or I'm 5 below ground. But if it's position wise, then it's positive. I had 24, I had 25. That's what I tell them without seeing value. We look at distance, can I travel a -5 from distance? And they're like, no. And some of them will say yes, some of them won't.
Position, underground, position below sea level as well. But the distance traveled is still
They used to make it, they used to make
watching, I'm just saying.
You find your name right, it's so different.
That's always the big deal. Have it custom
Now because I was actually just sitting there twice, and that's rare, but.
A little bit more, but sometimes if you're giving an unusual name, and you find out everybody has Laura, just so you know, Laura, when I was
But this one, you put 0.
I don't know, but the writing is really pretty, and it's like typed to.
Well, also looking certain parents and they can move or
So I write right here, so it's very. The very fine tip. So the finger's right here, so then it takes, and it's back.
I moved when I came back.
It's just when you write here, it gets very, you know, it's not as detailed, so that's the question. I mean, because
I didn't write it down.
I know, it's like, how did you do that? You like remembered all the numbers.
Yeah, that's better.
It tells me like this one.
But yeah, usually, I mean, he sits like 45 words, but whenever I do stuff,
Am I looking at just the value of age?
From my speed.
Find the difference? Or am I going
Now, my speed is this.
I'm missing this.
0, I didn't change position.
total distance?
Even though I changed it, just
Even though it's between A and G, I gotta calculate A through.
Okay, guys, I wanna share something with you. So Thursday morning, my son ran into the cross-country meet, and it was super exciting and fabulous. He finished. That's all we're gonna say about that. So, in this meet, the track, here's the starting line and the finish line. There's a 3-mile course, and it went around like this, and they ran, and then they came back and finished right here. Okay, it was 3 miles total. My 6'3", 200-pound athlete ran it in 22 minutes.
That's pretty good.
He finished. And his cross-country career ended right there. So he did this course in 3 miles in 22 minutes. What was his velocity? Over from the start to the finish.
20 seconds more.
Okay, so his velocity, we know, is the change in position divided by the change in time. So Davis Gibson, his position started here, he ran the course, and he ended here, so right there. What was his change in position?
He didn't move anywhere.
He didn't, yeah.
He didn't know
Do not measure your cross-country time. You don't measure, that's why they don't do velocity in cross-country, because it would be really depressing. So his change in position was 0 miles, and it took him 22 minutes to do that 0 miles. So his velocity was 0
Miles per minute.
miles per minute. Now, that's not how they determine who gets to go on to regionals. No.
Easy, everybody.
Nobody would do it. Okay, but here's what they do, is they calculate the average speed of the runners. The average speed is the total distance that they covered divided by the total time it took them to run it. Now, I've been to middle school cross-country meets, and it's pretty hysterical because there's a lot of vomiting that goes on at those little things in the middle of the race. Some of them stop to throw up, some of them don't. So their running time is not an average constant speed. So you calculate the average speed over the course of the race. So the total distance that Davis covered was 3 miles. I'm sorry, the total time, took 3 miles. And he traveled that 3 miles in 22 minutes. What was his average speed?
1300s.
Is it really?
Yeah,
I hadn't
that looks
calculated.
right.
Okay, it was what?
Rounded is 1300.
1300
Miles
per miles per minute. So while his velocity was 0, he traveled that velocity in 22 minutes at a speed, an average speed of 1300ths of a mile per minute. Yeah, well, he finished.
So was that like
Okay.
bad?
I'm sorry?
Was that really bad? About approximately 7 minutes a mile?
At a 6A high school?
Oh, I don't know. What's
That was a poor showing. Okay.
Sounds like amazing to me.
You gotta take a
Yeah,
reference
it's
his height,
amazing
against
to
the
me, too.
wind, he has more body.
So do you see, did y'all come up with similar results in your calculations between points? B, not B and D, but A and G?
Yes.
So if you look at your table,
Wait, you asked for similar results?
I mean, not like numerically,
Oh, okay.
but that your velocity and your speed were different, your average speed and your velocity were different? Yes.
And I was just, on the thing you labeled average speed, so you didn't label average velocity. You said velocity.
Is it?
Average is
Yes,
critical.
it's average, yes. Right, thank you.
We were discussing.
So if you look at your difference table here, when you're calculating your average velocity, you take your beginning position and your ending position and find the difference. And then you divide it by the time it took to go from one position to the other. So you're starting at position A at 0 meters, and then you end at position G at 0 meters. So 0 meters minus 0 meters is 0 meters. And the time it took to get to that 0 meter difference is 6 seconds. It doesn't matter, because distance divided by time is, or 0 divided by anything is 0. So your velocity was 0. But your speed, on the other hand, was different. The speed is the distance traveled and how long it took to travel that distance. So what was the distance traveled for this dog between A and G? How far did he walk? 4 meters, okay. And how long did it take him to go those 4 meters?
6 seconds.
6 seconds. So then our speed on between points A and G our average speed between points A and G is 0.67
6,600.
6,600, thank you.
Meters per
Meters per second.
With a repeatable.
So, and be sure when you're writing velocity and speed down, that you're writing average velocity and average speed.
So does the, I don't know, the capital V for velocity mean average? Or should we add an extra symbol to mean average? Instead of writing out the words average velocity, because the formula on the paper just has a V.
In physics, we will write a V and then put AVG.
Average, okay.
So.
Oh, subscript, okay.
We know that it's average.
Got it.
They would put, and then they would use VG to mean,
So what you,
Well, they're using it.
what the question is how do you distinguish between instantaneous velocity or average velocity? How do you identify that it's an average velocity? So rather than writing out the words average velocity or average V, you could write V
Subscript,
subscript
AVG.
AVG.
And sometimes they'll just put a V with a bar over it.
V with a bar over it.
Oh, okay.
Oh, that means average.
And then, wait, you could put a V with a little happy face right between your top so. Because all we're doing is inventing symbols.
Then you can add a
I
body
like
and
the
some legs.
symbols.
Arms, make those happy arms.
Running Man.
Okay, so what does this tell us about our dog's motion? What do these calculations tell us about our dog's motion? We did 2 calculations, but what does it tell us about the dog's motion?
Went awfully fast to go nowhere.
They can text really quick.
I said velocity deals with position, which tells you where the dog is over time, whereas speed talks about, or uses distance, which tells you how far the dog has traveled.
Okay, okay. Did y'all hear that? Okay, so the velocity deals more with position, whereas the speed is about the distance traveled. Okay. As the police shared it. Okay, let's,
I just had this picture, talked about before, but of a dog with a tape measure, you know, those construction tape measures?
yes?
And it's attached to the dog's collar, and the tape measure, or somebody's holding, but it's on a pole, and it swivels, and the dog's going in and out, and it's measuring.
Oh, okay.
So as it gets closer to the pole,
It's comes
it's
back in.
getting, yeah, it's shorter.
So is that a position or a distance?
It's a position,
Good. I like that.
as
That's a-
opposed to
that's a
a
good way to
pedometer or
think of it.
Fitbit attaching your
Yes.
feeding, and I've heard putting your Fitbit on your dog.
You just walk in place and you do this, and you don't have a heart rate just phone, you just track your steps.
You asked a question and I didn't hear.
It's so sad.
Was it-
No, listen.
The question you asked her was, did you ask whether it was a distance or a position? Is that what you asked her? I can't remember which question.
What
She
What
said
did you
position.
notice?
did
The
I
dog
ask?
on the tape.
She was just bringing up an example
I
of,
know.
It's a position,
Is it?
because whatever the tape measure, it starts to retract, like the numbers, it doesn't, let me think before I say something. The tape measure is not recording how many times it goes in and out. It's, as the tape measure comes back, the numbers that it's showing is less.
Okay, now what if the dog ran past the starting place and went farther?
Right, and
Could
then,
he be at the same positions?
right, because
on
the
the
tape
tape?
measure's gonna say the same thing. So that's
Is
where
it-
the flaw in the
That's what I'm
logic.
wondering, is it's a matter of reference positions and reference lines. Because whenever we talk about plus or minus on a reference line, if you have a point that you call 0, and then you measure to any distance from that point,
Right.
okay, is the distance you're measuring telling you a position?
From that 0,
Probably 6 negative.
you wouldn't have a negative though if you had that
In
point.
math people, I have a question. What is the definition of a circle?
The same equal distance from the middle.
So you're measuring distance? If you were gonna make a circle in your yard and you stuck a post in there and then you took a measuring tape, did you measure position or distance?
Oh,
Distance.
Distance.
could be distance.
Then I get put position.
Position.
Distance from the
This is the
state.
dumb science teacher
It's the same
asking.
distance.
Well, if you have like a stake, and you wanna go 5 meters every single way,
Right.
that's distance, you're saying 5 meters this way, this way, position.
If it's not equidistant, then it's oval.
Yeah.
Yeah.
All I care about
Because
is,
you don't,
does the
What the
does the
position
measuring
it's a positive or
in a
negative, so you
situation
don't, you're not
of
talking about direction.
measure distance or
So you're talking
position?
about distance.
Distance.
Do you have tick marks
But you can't have
on the things?
No,
You know what I'm saying?
no.
No, but
At this
again,
position, he's just distance from
I'm
center.
on a number line, I could be 6 meters away or whatever.
Yeah,
It
yeah.
doesn't matter.
And I think actually it's assuming that it
Well,
is.
it's a
Just back and
distance.
forth and along.
But you measure the distance when they reach a certain
See,
position.
I think this, the point I'm bringing up is, it has to do with education. I don't know what age level do you start to teach about polar coordinate systems. But a polar coordinate system is ideal for where would the dog be based on how far, the distance, and on the circle, what direction. So you have a reference direction, we call it 0, and then 360 degrees going around it. So you can say, at this angle, at this distance, that's a position. Whenever we use a number line, we have this distance, that's the number, and a plus or a minus to indicate the direction.
Okay.
but I think there, you're looking at tangent to the circle. If you're looking at that point. Okay, now if you're saying that that dog's going in a circle, it's constantly accelerating.
You can use a polar coordinate system to
Right.
describe the motion of the dog,
Right.
no matter what it is. With just distance and direction.
X and Y,
No,
no, just X.
R and theta.
Okay,
How far and what direction?
If you're gonna put that
How
picture.
far and what direction? So
What the
the
state
basic idea is this,
does.
I'm trying to do this. We have a tendency in our own minds to think that a Cartesian rectangular coordinate system is like the essence of it all. And it's really not. What it is a three-dimensional spherical coordinate system. That's what you live in. How far away and in what direction? How far is it? Is it to the left or right, up or down? So when you live in a three-dimensional spherical coordinate system, that you can't introduce the coordinate systems with that. But how do you get from the ideas? That's why we were talking about position versus distance. What's the difference between those two? On a number line, plus 2 is 2, it's the same distance from 0 that minus 2 is. But it's not the same direction.
Oh, okay.
So the position would still be 2,
What position?
at 2 or negative 2,
Okay.
but the distance,
It's the same.
Distance.
The position is different.
But the
So I'm
distance
not
from
backwards.
zero.
The distance from 0 is the same.
distance from 0 is
From
same,
0 to 7.
but the position,
so are you saying it's the absolute value?
Distance is the absolute value.
This is absolute value.
So,
Maybe we thought that
so
way.
across what I say,
We teach
So
this.
distance is the absolute value.
They just think it's the absolute value.
So,
So that difference absolute value. is
so I think we need to be very cognizant of our language with the position and the distance, because it's very complicated. So what we felt like, I mean, when I heard Ashley speaking, I was visualizing linear, not a three-dimensional option. I was visualizing linear rather than backing up and imagining the options. So I was inferring, according to what you said, my own beliefs, and that's not what I should have done, right? Because what I heard might have been different than what everybody else heard, and so that could reinforce misconceptions. Okay, so let's go to part 2 on this next page, number 1. We're gonna make 2 graphs.